All right, so back, this is part 2 of section 3, question number 36. All right, question number 36. Consider the function f of x equals 2x squared plus 6x minus 8. What is it in vertex form? If you do not know what is vertex form or anything of that nature, which that's a great possibility, go to Desmos, which is the graphing tool, and let's first enter in our basic function. Okay, so we're going to enter in our basic function, and that is, let me use this here, that is 2x squared plus 6x minus 8. All right, so there, as you see the graph there, so now what I'm going to do is I'm just going to enter in my answer choices. I'm going to say 2 parentheses x minus 3 close parentheses squared minus 4. All right, is that the same? No, so that one's not an answer choice, right? 2 parentheses x plus 3 close parentheses squared minus 4. Right, that's not the same as the red, not an answer choice. Let's go with 2 parentheses x minus 1.5 close parentheses squared. I know these aren't answer choices, so I'm getting them out of there. And then go back to minus 12.5. All right. Is that an answer choice? Did I put it incorrect? Yep. Is that an answer choice? No. So that means D is going to be my answer. Right? D is going to be my answer. And let me show you why. Because 2 parentheses x plus 1.5 close parentheses squared minus 12.5. Where did I go wrong? Oh, I didn't. KP, that got me. All right, you see the black becomes the red. Okay, you see where the red goes right over it, so that is the answer. So now we're on part B. Guess what? Do the exact same thing, okay? So now we're on part B. We're going to do the exact same thing. We're going to say parentheses 2x plus 1. Yes, ma'am. Yes, you can. Open parentheses again. X minus 8. All right, and if you click and hold, I left clicked. And I clicked and hold. It allows me to change. I'm going to put that as purple, or black, so that way you can actually see it. All right. So, is that the same as the red? No. What's different? They changed for the next one, right? So this is not an answer choice. For the next one, they changed that to a negative, and they changed that to a positive. All right, that's not an answer choice. For this one, let's see. For C, they said 2, move over, delete the 2, plus 4. So I'm going to say plus 4, and then x minus 1. So minus 1. Looky there. All right. Black's on top of red. That is my answer. Black's on top of red. All right. That is my answer. So I'm going to click next, and we'll move on to the next one. Okay. So here we go. Word problem. Consider the claim if point 2 plus d and y is on a graph of the function of f of x equals x parentheses x minus 4, then the point 2 minus dy is also on the graph. Okay, use algebra to show that this claim is true. Write what relationship is between the line x equals 2 and the graph f of x. Justify your reasoning. Okay, so we get to dive into a hard one here, and that's okay because you should have plenty of time to kind of get in and work out your stuff, okay? All right, so first of all, what you should have, right, is that if, let me click here, and then we will kind of type this stuff in. All right, so if you have 2 plus d y, right? If that is on the graph, that is on the graph of f, right? That's on the graph of f. Then you should have y equals f 2 plus d. If that's on the graph, right, of 2 plus d, so that means y equals f of 2 plus d. So now we're going to take it and we'll plug it into this equation here. So that's going to equal 2 plus d times, anywhere you have x, we're going to put in 2 plus d, right? So we have the x is, instead of an x, we have 2 plus d, right? Instead of the x here of the x minus 4, we will say 2 plus d, and then we're going to say minus 4. All right? So now we will simplify that, and that is essentially put the d in front. That's d plus 2, and 2 minus 4 is going to be d minus 2. Okay, so now if I factor that out, I use my FOIL method to multiply that. D is d squared, right? I have positive 2d, so I have a positive, it's not letting me write it that close, so I will move this down over here. So we have a positive, we have d squared, we have d minus 2, 2d and 2 negative d, those cancel each other out, and then 2 times the negative 2 is a negative 4. All right, and so all of that equals y. All right, so since y equals y, all right, therefore if y equals y, basically if the point 2d plus y is on the graph of f, then so is this one here, 2d, all right, so is this one here, 2d, 2 minus dy, okay? So if y equals y, then it's one of those things that if 2 plus dy, 2 plus dy is on the graph, 2 plus dy is on the graph, all right? If 2 plus dy is on the graph of f, then so is 2 minus dy. All right. What does that show? All right. What is the function of x? Okay. What's the function of x? So if I would put this into Desmos, all right. If I were to put this into Desmos, no, not that. I want to put it here, and I want to put in. Let me find a good spot so I can do that. If I would put this in, and let's say that I get, like you said, it's d. So let that be x squared. So x squared, right, minus 4. Okay, x squared minus 4. If I plug this in, okay, it says for it, what is the value, okay? What is the value? It says, what is the value of x, okay? What is the value of x? Wait a minute. Where did I go wrong? Just for a second. All right. It says what is the value of x? Well, in this case, right, x is going to be the line of symmetry. Okay. X, of course, is at this point in time, x is going to be the line of symmetry. Okay. So the line x equals 2 is a line of symmetry. Okay, it's going to be a line of symmetry for the graph of f. For the graph of, can't write it no more, of f. Okay, for the graph of f. Okay, I know this because the x values are the same distance, which is the absolute value, right? The absolute value from 2, it yields the same distance in the functions. Okay, so they're the same, different apart. Okay, they are the same distance apart. That's how we know this. Okay, let's move on, especially for time's sake. These are going to be kind of rough, these last ones. By no means should you put IDK. If you put IDK, you're just kissing points away. All right, you need to just give them a shot. You need to try them, okay? At no point do you put IDK or I don't know or anything of that nature. That guarantees you no points. Just try. Just start putting stuff in there and trying, okay? All right, so it says Melissa launches a rocket from a 3-meter tall platform. We see here, right? We see here if she's launching a platform, right, 3 meters. So that means this right here, it shows that she's launching from the platform. She's not on the ground. The height of the rocket in meters can be modeled by this. Melissa knows that h of 1 equals 23 meters, okay? And h of a is 34.25, okay? So what this is showing here is that this is my model here. Think about it, okay? If you launch something into the ground, you launch a rocket, it's going to go up in the air. What's the unit of rate for something that's going to go up in the air? All right? In this case, it says meters, right? So this is over here on this side. This is going to be our meters, okay? What could be our x value? Think about it. If something goes up in the air, we see how high it goes, and we also can measure what? We also can measure how long it stays in the air, okay? We measure how long something stays in the air. When we throw something in the air, we want to see how high it goes up and how long it stays in the air. And so this is usually time, okay? The x down here, that is usually time, okay? That is usually time. So she knows that h1, what that means is that h1, that means after 1 second, it's 23 meters in the air. After a seconds, it is 34.25. This here, which is 34.25, is my max. That's my maximum. What is a reasonable estimate of the rate of change of the height of the rocket in meters per second? There you go. It tells you per time between A and B, and explain. So it wants to know what is a reasonable assumption. What is a reasonable assumption between here and here? What's a reasonable assumption of the rate of change? Okay, what is the reasonable assumption? Well, first of all, what we see here is this. Do we see the solid line like we see on all these others? No, that means that dotted line is on top of that solid line right here for A. So that means that A equals 2.5. So now we have two rates of change that we know. Okay? We know that this is 1 and this is 23, and we know that the h here, right, we know that it is actually 2.5, 34.25, okay? That is the things that we know. So we know h, right? We know that h of 2.5 equals 34.25. Those are things that we know. Using this information, we could determine a rate of change, right? So we'll say my rate of change in between 1 and 23 and 2.5, 34.25. My rate of change is y2 minus y1 over x2 minus x1. This is something you should know. So I'm going to say 34.25 minus 23 over 25 minus 1. And that's going to give me 11.25 over 1.5. I divide that again and I get 7.5. So that's 7.5 meters per second. Okay, sorry, the second didn't really write there. All right, so looking at the graph, right? If I take a look at the graph, here is, right, there is that one there. This is my maximum, right? Where does B fall? Where does B fall? All right, so this is up to the maximum, right? This up here is to the maximum, okay? So can we estimate? What do you estimate B here? B is about how many seconds? What do you think? How many seconds is B? No, it's not 4, because if it was 4, it would be on that line, right? It's not 3.5. All right, so look, take a look. It's closer to the half. So it's not going to be 9 because it's not closer to the 4. So we'll say B is, let's estimate it as 3.6. What can we estimate H of B? H of B is a little bit north, and so we can call that 28, right? So let's say H of B is approximately 28. So we know what our rate of change is. Here is our next point. So we just have to simply determine, hey, so what is it? So let's apply that. We'll say 34.25 minus 28. And then we're going to say 2.5 minus 36. And that gives us 6.25 over negative 1.1, which I put that in the calculator. I get negative 568 meters per second. Okay, is that a reasonable estimate? Is that a reasonable estimate? Well, yeah, because whenever it's going up, right? Whenever it's going up, it goes up to the maximum, right? Over a longer period of time from 1 to 2.5, that's a longer period of time from 2.5 to 3.6, okay? But think about also, what does a ball do when you throw it? And it reaches its maximum. What does it do? It kind of slows down, right? It kind of creeps up, it hits its maximum, and then it starts slowly coming down, and then it starts plummeting again, right? So that is basically within the realm. Now it says it wants us to an average. What is a reasonable estimate? A reasonable estimate would be you can just say this, or you can say about -6 meters per second is the average rate of change, right? So average rate of change, your average rate of change, I kind of ran out of writing room, sorry about that. Your average rate of change, right? Your average rate of change between A and B, okay? So you would say, just quote what it says here. You have a reasonable estimate, right? A reasonable estimate. And you have to explain your reasoning. So you have to type in this math, but it would be a reasonable estimate of the rate of change from A to B is -6 meters per second. Okay? So you need to, all right, so it says explain your reasoning. You need to show your work. So you got to type all this in. You'll have to type all this in, okay? And then you will have this. You got to have the correct estimation for the average of rate of change to get 1 point. You got to provide your mathematical reasoning, that's here, and then display correct calculations used to derive the estimate for the rate of change. So you got to do your math, type in your math, make sure your math's correct, and then you got to have this over here, which is your answer choice. Okay? I know it's a lot, but that's why these are at the end. All right. So our last thing is number 39. A high school is having a talents contest that will give different prizes for the 5 best acts in the show. First place wins the most money, and each place after that wins $50 less than the previous place. Create a model that can be used to determine the amount of prize money that can be valued of the first place prize. All right, so this is a two-parter. We see here it's a two-parter. All right, so this is part A. Basically, this you have a person that wins, they get X. We have 5 prizes, right? So the person that wins gets X. The next person will get X minus 50, right? The next person, which is the third person, will get X minus another 50. So that'd be minus 50 minus 50. The fourth person will get X minus 50 minus 50 minus another 50. And then finally, the fifth person will get, again, this is a plus here, a plus, X minus a 50 minus another 50 minus another 50 minus another 50. So if I put this into decent stuff, right, this is X plus X minus 50 plus X minus 100 plus X minus 150 plus X minus 200. Okay? And that equals, and we're going to say that equals, what are we talking about? Prize money. So we'll say that equals P. All right? That equals P. All right? And so it says create a model to determine the total amount of prize money. Well, there it is there. That's the total amount of prize money based on the value of first place prize. Well, what is the first place prize? X, right? So there's my equation where X is the first place prize, which is what they were looking for, right? Check. Total amount of prize money. And P is the total amount of prize money. All right, there's that one. Okay, so there's that one. So this is just my work. All right, there is my answers there. It says enter your model in the box provided. So this here, let me change my color. All right, so this here, that's my answer. Okay, sorry, this was just my work up here up top. All right, so that would be my answer. And then make sure, that's the thing, make sure you're doing everything. Read this stuff. Make sure you're checking off what they tell you to do. Create a model. Did I create a model? Yep, right there. Check. Created a model. That can be used to determine the total amount of prize. Did I use the total amount of prize? Yes. Did I define it? So there's the total prize. I defined it there. The value of the first place prize. All right, is it based on the first place prize? How do I know that? Well, X is the first place prize. Yep, and it's all based on X because X is the only variable. So there you go. I met all the requirements. So let's move on. High school talent show, same thing. If the talent contest has a total of $1,000 in the prize money. So now we're saying that P equals $1,000, right? Based on our previous stuff. Our previous stuff was X plus X minus 50 plus X minus 100 plus X minus 150 plus X minus 200. And that's going to equal P, right? Which is $1,000. So if I simplify that, I get 5X minus 500 equals 1,000. So add my 500. That is 5X equals 500. Divide my 5, X equals $100. Okay? All right? I'm sorry, X equals $300. $300. I can't divide for some reason, right? Because that's $1,500 and that would be $300. So it says, what is the amount of money for each of the 5 prizes? Okay? What is the amount of money for each of the 5 prizes? So I'm going to say 5th place. All right, 4th place, 3rd place, 2nd place, 1st place. 1st place gets how much? 300. Then I drop 25. That's 50. I drop another 50. That's 200. I drop another 50. That is 150. I drop another 50. That is 100. Okay, show your work, enter your answers and your work in the box provided. All right, again, this is one of those things that if you don't get A right, you can't get B right. All right, and that is the end of our session 3 test, our constructed responses.